topic 15.2 entitled The Formal Definition of the Definite Integral. So for this topic, you are expected to define the definite integral as the limit of the Rayman sums. In any case, we know that the above Rayman sum is only an approximation of the exact R. To make this estimate exact, we let n approach infinity. This limit of the Rayman sum is what we call definite integral of f over the interval a to b. So again, katong Rayman sum na to is just an approximation. So dili gyud siya exact. So para makuha nato ang exact, ang ginabuhat kaning n na to ginapa-approach na to infinity. Usay pasabot-an ang n. Katong n is katong number kung kapila nato siya gi-subdivide. Kaya kung gamay ra atong pag-divide, dili kaayo daghan kaayo butal o na manubra diha. Ana. Unlike kung atong daghanon og taman up to infinity, mo approximate siya to the exact area. So this is now our formula for sa definite integral. So for the definite integral, so kung tanaw na to medyo makakabuhi na formula. So that is integral of f of x dx from a to b is equivalent to the limit of the summation of f of x asterisk sub k times delta x, where your k starts from 1 to n as your n approaches to infinity. So ato to pagkabasa, so ato na lang buhaton is i-apply nato na unsaon paggamit ni nga formula. So again, ang definite integral is actually the limit of the Rayman sum as your n approaches to infinity. So let's use that definition to compute areas using the formal definition of the definite integral. So the problem with the definition of the definite integral is that it contains summation, which needs to be evaluated completely before we can apply the limit. So for simple summations like summation of k raised to p, where your k is equivalent to 1 to n, up to n, your p is a positive integer. Formula exists which can be verified by principle of mathematical induction. However, in general, formulas for complex summations are scarce. So ang point lang ani, before nimo ma-apply si limit, you should simplify first the summation. So actually naapoy part kuan, naapoy mga formula nga magamit nimo about sa summation. I-present ko na kuan. But ang uban manggod dili manggod daghan, dili kato from the word scarce, murag gamay ra ang mga formula for complex summation. So ang atong i-present lang kato lang mga basic lang code. So in the next examples, this illustrates how a definite integral is computed by definition. So we start with how to compute definite integral using the definition sa formal definition sa definite integral, which is ang ganina. Ang definition sa definite integral is just the limit of the Rayman sum. Kay kaning summation Rayman sum na. So let's discuss example 3. Diretso na ko sa example 3 ha. So the problem is show that the integral of 3x plus 1 dx from 1 to 3 is equivalent to 14 using the definition of definite integral as the limit of sum. Let's visualize this one first. When you say kaninga usay pasabot ani, actually it is just the area sa, let's say 3x kani ang assuming lang ha kani ang 3x nga graph, ang kani nga graph is 3x plus 1. 3x plus 1 na siya, linear siya actually, line man eh, kay linear man na. I-assume na lang ako nga paana, and then x equals to 1, and x equals to 3. So, nadali si 1 and nadali si 3. Asa nigikan si 1 and si 3? Kaning 1, ang 3 na ara. Asa ning 3x? Kana. So, when you say again integral, it from 1 to 3, it is the area bounded by katong imong integral nga 3x plus 1 ug katong x equals to 1 ug x equals to 3 katong boundary nimo ug ang x-axis. So ang gi-question na unsay area ani, actually ang area daw ani based sa kuan is 14. Mo nay pasabot ani nga kaning notation that the integral of 3x plus 1 dx from 1 to 3 is equals to 14. Pasabot ang area bounded by the curve 3x plus 1, x equals to 1, x equals to 3, and the x-axis is equals to 14. Mo'y pasabotan na. But, atong punto is, we will be, ipakita nato ni nga this is true using definition of definite integral as limit of a sum, which is mauma na ang atoang objective, kumbaga. So, to start with, kailangan sa nato solvon ang Rayman Sum nato. So before ta mo abot ani, isolve sa nato ang atong Rayman Sum using the kaninga formula. Ang Rayman Sum, summation of f of x sub k delta x sub k where your k starts from 1 to n. So, unsa po ning f of x sub k? Kaning 3x sub k plus 1. Asa po na siya gikan? Diri na siya gikan sa given nga 3x plus 1. Dipulihan lang nato x sub k si x. So, I hope naka-follow. So, after ana, kaning delta x sub k where your x sub k starts from 1 to n. So again, ang first button from this equation, pulihan nimo ni base dire. Pulihan lang nimo si x of x sub k. So next step ana is to determine kaning delta x sub k. Kung saan nimo pag-determine sa delta x sub k, actually, kadto lang boundary nimo from 1 to 3 man na. So 3 minus 1 divided by n. Mao po ni ang formula na to. B minus A over n. That is our delta x sub k nga formula. So ang B na to is katong upper limit, lower limit atong A. Okay, so therefore we have 3 minus 1, that's 2 over n. So nanatay, kani. So next is kailangan nato i-solve ning x sub k. Unsa pod pag-determine sa x sub k? Kani pod ang formula. You have to take note of this. X sub k nga formula kani ang delta x sub k, I mean, mao na formula, ang x sub k kani pod x sub k equals to x sub 0. Ang x sub 0 actually kato ng lower limit. Let's say you can use a na lang para for consistency na sa variable. So that's a plus k delta x sub k. Plus k delta x. So mo nang formula na to. So since na tayo formula and naan naman tayo a, again ang a na to is the lower limit. So mo tong na ay 1. And then kaning delta x na to na naman na dire, na-solve naman nato na. So, substitute na lang. Mo nang na 2 over n. Then, simplifying, that becomes 1 plus 2k over n. So, na-simplify na nato. So, now, we have kani o naani. So, pwede na nato i-substitute dire sa atong equation. So, meaning, ang Rayman sum na to is the summation of the quantity 3. Asa ni gikan si 3? Kana. Asa ni gikan ning 1 plus 2k over n. Diba ang x sub k man na diha? Mo man po ning x sub k na raw. X sub k equals man na ana. So, substitute lang niya diha. Sunod, plus 1. O nang plus 1 diha. And then, times delta x sub k. So, substitute na nimo sa x sub k dire, which is 2 over n. So, diha nagikan. I hope nakapollow. Next is, from here, gikan dire, ato na siyang i-simplify. Simplifying this one will become ana. Asa nagikan si 4? Actually, that is just distribute si 3. That's 3 plus 1, motong na 4. Next, distribute si 3 na po diri, mo nang na 6k over n. So, n as easy, 2 over n. Okay, we hope, again, nakafollow. Next, simplifying na po kani nga part, i-distribute na to si 2 over n pasulod. So 2 over n times 4, that's 8 over n. And then 2 over 4, 2 over n times 6k over n. So mautong na 12k over n squared. So nanatag na rin nga part. After ana is we need this. You have to take note of this na pod. So, idugang ni sa inyohang formula. Take note, kani, formula bank ninyo, katong delta x sub k na b minus a over n. So, kana mga kuan. So, mao ni isa sa mga important summation formulas. Kung makakita mo summation of 1, again, kung makakita mo summation of 1 from k equals to 1 to n, up to n, ang answer ana is n. Kung unsay value sa imong n. Then summation of k from k equals to 1 to n, kanipod. So how can this be used in our problem? Padayon ta. From this one, diretagi ka na, we will use this summation equation. So take note nga kani ang nganong naa sa labas ni i-factor out lang niya. So kung i-factor out nimo si x 8 over n, 1 na lang mabilin. Kani pod i-factor out niya ning 12n squared. So naa sa labas si 12n squared. So k na lang nabilin. So mao na ang kailangan nato ni karon sila duha. Okay, because summation of 1 from 1 to n is just equals to n. Matong nakambyoan na siya n. Kay kani, again, ang kani equals naman kay n. While ang kani equals na pod ani. Asagikan diha. Ang summation of k from 1 to n is just n times the quantity n plus 1 over 2. So, mo nang nainani ni. So, again, hopefully, nakapollow. Next, simplifying this one, makancel out man ni. So, mo nang 8 na lang. And then, kani actually, 8 na lang no. Anong na 6 man eh? Kaning 12 og 2, 12 divided by 2 mo ng 6. Tapos, yung i-distribute nato na that should be n squared plus n. Di ba? Tapos naman tayo n squared dire. So, over n squared. So, kung isa-isaho nato nag-divide, n squared over n squared plus n over n squared, so, motong na ay 1. Kaya ang n squared plus over n squared is 1. Then, n divided by n squared, morning 1 over n. So, dari na ta karon. So, after that one, we proceed to, okay, balik na to ha. Actually, dari ta nag-stop. We now proceed, kato nang, na-solve na nato ang Rayman Sum. Mao na ning Rayman Sum na to. We will now use the definition. Again, ang integral of f of x dx from a to b is just the limit of your Rayman sum as your n approaches to infinity. So, limit lang aning Rayman sum. Ang Rayman sum na to kaniman, limit ani as your n approaches infinity. So, how to simplify that limit? Limit as n approaches to infinity. We need this one. Naani actually sa previous lesson dapat, pero na lang na ako i-discuss again. Diretso na taan eh. Just take note of this. When you see limit of a number over n as your n approaches infinity, ang answer na is 0. So take note of this na lang, kumbaga nga theorem. Limit of 1 over n as your n approaches to infinity is 0. So therefore, ang limit ani is actually 0. As your n approaches to infinity man, so meaning 0 ni. Mahimo ni siya 0. So 1 plus 0, 1 na lang. Tapos 6 times 1, mahulog man na, this becomes 8 times the quantity, this will become 8 plus the quantity 1 plus 0 man, 6 na day 6 mana. So kani, asa nigikan si 0 because ang limit sa 1 over n as your n approaches to infinity is 0. Tapos 1 plus 0, mahimo na siya 1. Tapos 6 times 1, that's 6 plus 8, otong 14. So therefore, we just prove using the definition that the limit of the integral of 3x plus 1 dx from 1 to 3 is equivalent to 14. So we have presented the definite integral using Rayman sum. So in ato pag-present, in atoon pud pag-solve sa inyong written works actually. So kasabot ko nga medyo dili pa kay dayon masabtan, but later at least na ay gamay nga makuha-kuha ra. So para mas masabtan pa, let's have another example. So another example is use the definition of the definite integral as limit of a Rayman sum to show that the integral of x squared dx from 0 to 1 is equivalent to 1/3. So ang ato actually given na ta answer. Ang ipakita na lang nato is i-prove nato siya using the definition of the definite integral as the limit of the Rayman sum. So same process ganina, ang buhaton nato, kwaon sa nato una si x, delta x, katong delta x sub k. So again, unsa ang kanio? Mamo ni ang formula, di ba? Kailangan sa nato unahon si delta x sub k. No, solve sa nato na una. Tapos to solve delta x sub k sa ganitong formula, di ba, b minus a over n. Where our b kaning nasa taas, that's 1. Our a is kaning nasa baba, minus 0 over n. So clearly daw, that is 1 over n. So muna, delta x na to is n. Nanong nawala si kuan? Ang k naman, so therefore, ang delta x sub k na to actually is mao na tong 1 over n. So nanatay 1 over n. Okay na ta na. Next, kailangan po na to si x sub k. Okay na ta ni x sub k na po. Again, to solve for x sub k, atong a plus k delta x. So ang a again is 0 plus k, tapos ang delta x na to is 1 over n. So 0 plus k times 1 over n, nara, ang final answer is k over n. So naana atong mga kailangan ang delta x na 1 over n, ang x sub k na k over n. We can now substitute it in our formula sa Rayman Sum. So again, ang formula sa Rayman Sum is kani f of x sub k times delta x sub k. So substituting f of x sub k kanina siya. Asa pod ni gikan. Kailangan una kuhaon nimo si x sub k, which is morning. Again, kailangan nimo isolve si f of x sub k using kaninga formula. Mao na atong, diba, ang f of x na to is katong given nga integrand x squared. So therefore, our f of x sub k is equivalent to x sub k squared, which is our x sub k, given naman ang x sub k na to, nara, x sub k na to, na-solve naman na to nga k over n squared. So, mo na siyang nahinganin na. So, I hope na ka-follow nganong asa na gikan. And lastly, kaning delta x sub k, nara, na-solve na po na kanina. So, mo nang 1 over x sub n. So, okay, let's proceed. So from this, ang kailangan nato is kani, kay naamantay k squared manggod. Kung sa ganito ganina, ang naalang nato is summation of 1 o summation of k. So wala, ang ato ang problema, summation of k squared man. So kung summation of k squared po ang problema, kani po ang kailangan, kani po ang equation na 1. So you have to take note of this again. So butang ni sa inyong formula bang. So from this, masimplify naman ni as, ipalabas na to si 1 over n. So 1 over n, ang 1 over n cube na, actually this, okay, simplify sa nato ni ha. This becomes summation of k squared over n squared times 1 over n. From k starts from 1 to n. So anak man na dapat. And then simplifying, that becomes summation of k squared over n cubed, where your k starts from 1 to n. Tapos kaning 1 over n dire, actually naani 1 diha, mo tong i-factor out niya para ang mabili squared na lang. Kay kaning summation of k squared na aman tay formula ana, which is kana. So i-substitute na lang to niya. So from here, i-copy lang na diha. Then ang kaning summation of k squared from 1 to n, i-copy ra pud dire. So mao na diha. So I hope naka-follow. Then simplify na lang ni kanina part. Simplifying this one, dun sa ni pag-simplify, mag-foil sa kani, tapos i-distribute si n. So meaning, n plus 1 times 2n plus 1, foil method ka. Ang answer ana, distributan ni mo n, kaya napa may n diri. So pag simplify ni mo, kani ang mo labasan ni. Kana. So assuming na solve na nimo, so mao na ni, simplify na pud nato ni kani nga part. Kay naman tay n squared diha. So isa-isaho nato nag-divide og n squared. So actually ang pag i-simplify nimo na, mahimo man na nag 2n cube over n cube plus ano pa day 6 day, sorry. Isa-isaho nato, ang denominator nato is n cube og 6. So isa-isaho nato sila divide og n cube og 6. So after sa 2n cube, kay kani man gud 1 og kani, pag i-multiply nimo as extra man na. So sunod sa n cube is 3n squared over 6n cube na pod. And lastly is ang n, i-divide na to 6n cube gihapon. So pag i-simplify nimo ni kana, that's 1/3. Ang n cube makancel naman. So ang mabilin 1/3. So mo nang 1/3 na. Kani 3 ug 6 1/2. So natay 1/2 tapos nara 1/2. Tapos n squared lang man ni sa taas, cube man sa baba. So matanggal ni si n squared pero kani mabinlan pag isa kay squared ra man ang makancel. So mo to na ay n pa sa napay n nga mabilin. And then, okay. Next is, lagay na po na-adjust. Sige, dakuan na to. Yun. So, lastly, kaning sa last part na to, as E.C.6 sa denominator, mo nang na I6 dere, tapos n lang man makancel si n exponent 1 man na, pero kani napay squared. Kay 1 lang may makancel. So motong na n squared. So nanatay nga ni karon. Okay. So mo na karon imong Rayman sum, na simplified Rayman sum. So after that, apply na to nimong definition that the limit and the integral of f of x dx from a, the integral of x squared dx from 0 to 1 is just the limit of your Rayman sum from n as your n approaches to infinity. So again, recall that your Rayman sum, kanima na itong Rayman sum, di ba? So, pangitaan na lang natin ang limit as n approaches to infinity. Then, we will use katuganing limit of 1 over n as your n approaches to infinity is equals to 0. So, kani 1 over n man na, sumahin mo nig 0. Kanipod, 1 over n squared. Actually, that is 0 gihapon. So, unsay nabilin, 1/3 na lang. So, kaya 1/3 siya. So, this proves that the integral of x squared dx from 0 to 1 is 1/3. Unsa po'y pasabot ana? Ang pasabot again ana is it is just the area bounded by your curve nga kani, which is x squared o katong from 0 tapos 1 o ang imong x-axis. Kung kuhaon na nimong area ani, ang area ana is 1/3. Again, dili man ni siya triangle, so dili nato siya ma-solve using geometric formula lang, simple geometric formula. So moto kailangan siya og definite integral. So this illustrates the power of definite integral in computing areas of non-polygonal region. So ang isa sa mga gamit sa definite integral is to solve the area of non-polygonal regions. So kanang mga irregular nga mga shape, labinag non-polygon siya. Dili siya straight edge. So kato ang isa sa mga gamit niya. So let's dig deeper about definite integral. Let's discuss about properties of the definite integral. So ang theorem 17, let f and g be positive continuous function on a to b and let c be an element of real. So these are the properties. Actually, similar lang ni sa property sa limit. Since ang atoang integral involves limit of the Rayman sum, so kung unsa tong property sa limit, maura pod. Like pareani, na ang kay constant multiple, pwede ra nimo ipalabas si constant. Tapos addition and subtraction ng mga functions, pwede ra nimo isa-isahon. So mo ni pasabot ani theorem 17. So let's have an example. Suppose we are given that the integral of f of x dx equals to from a to b is 2, tapos integral of g of x dx from a to b is 7, find the exact value ani. So kani nga mga problema. So how to solve that one using the properties? So the first one, so since kani ang given, we can kaning 3 pwede natin palabas para kana na lang atong problema. And then based from the given, kaning na naman ni given naman integral of f of x dx from a to b nara. Kuman ang given. 2 daw na. So therefore, i-multiply lang nimo 2 si 3. So mo nang na 6. So next, about kani integral of f of x minus g of x from a to b. So using the property, pwede ra nimo isa-isahon. Then, since given man yung mga values ani, which is 2, and kaning integral of gx dx from a to b is 7, so i-minus ra pod nimo ang mga values. That is negative 5. Next, kani combination na natay constant, addition pa gyud. So basically i-follow lang ang ruling. So kung natay constant multiple, ipalabas. Tapos kung addition, pwede nimo isa-isahon. Then again, given man ni na 2 and kani pod given na 7. So solve na lang. So times 2 is 4 plus 7, that's 11. Lastly, kani combination again. Constant, di palabas. Kani pod constant, di palabas. Then minus man siya, so isa-isa siya minus pod. So naman tay value ani, which is 2. Kani pod natay value ana, which is 7. So multiply na lang si 3 times 2 kung negative 2 times 7. 3 times 2 is actually 6 minus 14. Mao tong na negative 8. So, inato lang kasimple ang property niya. Another property is this called additivity. Kasi pasabotan ng additivity. So, before ta mo proceed sa additivity nga property, kailangan nato ni i-discuss ni nga definition. Meaning, kaning first definition, let f be a continuous positive function on a to b. Then, the integral of f of x dx from a to a is equivalent to 0. Kung sa'y pasabot ana, pag naa kay definite integral, tapos ang imong lower limit o ang upper limit, parehag value, 0 na siya. No questions asked, diretso na 0. So, and ang ikaduha, the integral of f of x dx from b to a, ang lower limit niya is b, ang upper limit niya is a, is just equivalent to negative integral of f of x dx from a to b. Kung inyong mapansin, ang first, nasa baba si b, lower limit niya si b, upper limit niya si a. Ang dere, lower limit niya si a, upper limit niya si b. So, nagkabaliktad. Kasi pasabot lang ana. Pag magkabaliktad, muusab pod ang sign. So, meaning, ang kani, kung unsay value ani, negative nimo, baliktara lang iyang limits. Tapos, i-change nimo ang sign. So, nga na ang pasabot ani. So, let's try to apply that one. Oh, by the way, before that, we will use this one. I-consider po ni nga mga definition in applying the additivity of definite integral. Kasi pasabotan ng additivity, meaning kung nakay integral of f of x dx from a to b plus the integral of f of x dx from b to c, it is just equivalent to integral of f of x dx from a to c. Kung tanaw nimo ang first, pareha sila f of x. Pareha sila gintegrand. Ang nag-differ lang sa 2a sa ilaha is ang limit. So you start with a to b, sunod b to c. Kung tanaw na to, mura siya continuous rapod. From a to b, then to c. So pwede na nimo isahon, pwede na nimo i-add as isra from a to c na lang ka, di na ka moagi kay b. So motoy pasabot sa additivity. So example, suppose that f of x dx is from 0 to 1, as of 0 to 2 is equals to I. And integral of f of x dx from 0 to 1 equals to j. We are asked to find the integral of f of x dx from 1 to 2. So how will we solve that one? Given from 0 to 2. Given from 0 to 1, ang ginapangutana from 1 to 2. So actually, ang solution ani involves the additivity. Take note, this is from 0 to 2. Kani 0 to 1. Kani 1 to 2. So meaning, ang pinaka-lower na to limit is 0. Ang pinaka-higher is 2. So morning, murag gi-combine na si 0 to 2. So we can say that f of x dx from 0 to 2 is just equivalent to f of x dx from 0 to 1 plus f of x dx from 1 to 2. So tanawin ninyo from 0 to 1, then 1 to 2. So continuous siya. So equal na siya sa from 0 to 2. So mo ni ang working equation na to. Again, as an gikan is using the additivity property nato sa integral, definite integral. So from this, we can now substitute mga values. Because kani given man na nga I. Ang kani from 0 to 1, given man na nga j. So kani ang question. Mo nang unknown. So substitute na lang. So kani is I. Kani is j. Actually, mao ni siya. Gibaliktad lang niya. So kani is j. Kani. Gana. Ang I is kana. Ang kani actually, mao ni. Tapos kaning j. Mao na siya. So we can now use algebra. Since kani ang unknown, we will isolate this one. So isolating that one, kani si j, i-transfer na to sa pikas. By virtue of the addition property of equality. So therefore, this implies that integral of f of x dx from 1 to 2 is just 1 minus j. Because kani, pag i-transfer dito, man-negative naman na siya. So that's how to apply the additive property sa integral, definite integral. Another example. We have here, suppose we are given integral of f of x dx from a to b is 3. Integral of f of x dx, actually dapat na dx ni correct na lang na to. Dx dapat na from d to c is 10 and integral of f of x dx from d to b is 4. Ang ginapapangita is integral of f of x dx from c to a. Naatay a to b, natay c to d, natay b to d. Wala tayo ang question A to C. So, saan na pagkuan. So, kung tanaw na to, ang pinaka-last, pinaka-lower na to is A. Ang pinaka-taas is D. Okay, so we can formulate kani iyahang gibuhat nga kuan. So from ang C to A is equivalent daw ani. I mean from C to A, tama. Nagbuhat siya og additive property nga additive equation na ang f of x dx from C to A. Yung saan niya pagka-map using this one. So dapat baba si C. So nara nagamit niya ang baba si C. Tapos, C to D. Kaniyang gigamit, actually. C to D, pero gibaliktad niya. Diri, D to C man eh. So, kailangan niya ibaba si C because ang atong unknown, C man sa baba. So, diya siya nag-start. So, D. So, dapat, mag-D na po siya sa baba. So, unsay na ID, aside na kani. D to B, walay problema, as is lang. And then, B na po siya. B to A. Kani ang gigamit. Pero, gibaliktad niya. Again, para si B to A, kaning B dire, murag, kumbaga, imagine na lang murag mag-cancel ba? Dili ni proper ha, pero ang murag siya mag-cancel. Ma-cancel ni, murag na ba? Ma-cancel ni. So, para C to A na lang. Ingana niya ang pangkuan. So, take note, may mga baliktad. Ang punto lang niya is nagbuhat siya murag way na mag-abot si mahimo siya C to A. So, start siya C to D. Tapos, gibuhatan niya D to B. Kaya murag, kumbaga, again, sa inato, murag siya ma-cancel ni. Tapos, kaning B na pod, ma-cancel dere. So, ang mabilin, C to A na lang. So, by substitution, take note, na kaning C to D, wala tay C to D, na tay D to C. Which is, di ba natay property nga pagbaliktaron ang ato ang limit, ma-change ang sign sa ato ang integral. So, since kani 10, ibaliktad ang D to C, nahimog C to D na, so meaning, mahimo na siya, expected ma negative 10 ni, plus, from D to B. D to B man wa man problema, as is, so as is lang siya. And plus, B to A man pero kani A to B, so baliktad. So, dapat, negative 3 siya. So, yun. Kuan sa niya. So, moto, nara, and finally, simplifying, so same ta diri oh. Nara. Simplifying, we have negative 10 plus 4, that's negative 6, minus 3, that's negative 9. So, therefore, ang integral of f of x dx from C to A is negative 9. So, nato to pag-solve. So, nato medyo tricky siya na problem. And, another subtopic is this general geometric interpretation of a definite integral as a net signed area. So, actually, ang bottom line lang ani, when you say net signed area equals the sum of all areas above the x-axis minus the sum of all areas below the x-axis. In effect, we are associating positive areas for the regions above the x-axis and negative areas for the region below x-axis. So, yun. So, this is ang illustration. So, ang illustration na is kani. So, kung natay area, kanang area nga nasa taas sa x-axis, di ba mao ni atong x-axis? Mao ni atong x-axis kani. So, tanang area niya sa taas, positive na, negative ni diri sa baba. So, mao to, ang integral of f of x, mao ni atong f of x, kaning curve. From A, mao ning si A, to B, na si B. It's just, from A to B, is just equivalent to positive A plus C minus B. Minus si B because naa siya sa baba sa x-axis. So, ana ang interpretation sa geometric interpretation sa definite integral. So, ang definite integral actually is the net signed area. So, again, ang net sign is the sum sa tanang positive o tanang areas above minus the area below the x-axis. So, example. Interpret the following integrals as signed areas to obtain its values. So, example 1 and 2. We have example 1 and 2. So, for example, the graph of y equals to 2x minus 2 is shown below. So, ang point lang natin is interpretation lang man. So, meaning, if we have a graph nga parehaan kung tanaw na to, sabton lang nato na form niya is triangle. So, natay area 1 dari, natay area 2 diha. Ang area 1 nato, pilang area 1? Using the triangle nga formula, di ba 1/2 base times size, 1/2 area sa triangle is 1/2 base times height man, di ba? So, kung area 1 ta, triangle 1 ta, 1/2, ang base nato is kani. So, pila ning from 1 to 5, di ba 4 units man na? 2, 3, 4, 5. So, 4 units. That's 1/2, 4, times ang height nato dire, 8. So, over 8. Times 8, I mean. So, that is, nara di ay, nasolve na. 16. So, meaning area is 16. While sa baba, same niya po, area 2, area sa triangle 2 is 1/2 base times height. Ang base niya is kani, which is 1 unit. So, 1/2, nara. Ano na dire? 1/2, mao na yung base. Ang height niya is 2. We don't use the negative sign because height is a positive dapat nga kuan nga value. So, 1/2 times 1 times 2, that's 1. So, meaning 1 ni dire. So, from that, we can say that the integral of 2x minus 2 dx from 0 to 5 is 16 minus 1. 16 kay nasa taas, minus 1 kay nasa baba. So, therefore, ang integral niya is 15. So, nana ang pasabot niya sa geometric interpretation sa definite integral. So, next is nasa na ko ni. Next is the graph of y equals to sign. So, kung i-graph nimo, ingani ang graph niya. Ano? Tapos, kung tanaw na to, natay area 1, naputay area 2. If you can see, sa area 1 sa kani, area 1 na to, area 2, kung imong i-observe, actually identical sila. Parihara. So, meaning, kung pangitaan tag integral ni sin x dx based sa graph from negative pi to positive pi, klaro siya nga mo 0. Yan ang mo 0 man. Kay kani, positive, kani, negative, which is pareha sila, exactly equal ang value, positive, negative lang, mag-cancel out lang sila. Say for example, ang value, ang area lang ani, example lang ha, positive 10 na diha. Adiri po 10 po na diha. 10 yung area. Positive man yun ang area. Say pareha sila 10. So therefore, 10 minus 10 ta. Kay integral man. Nganong negative minus 10 man diri because below man eh. So therefore, tama ra nga ang integral niya is 0 because ma-cancel out man na. Again, because ang definite integral is the net signed area. Meaning, the area, the sum of the area above the x-axis minus the sum of area below the x-axis. So that's all for topic 15.2 entitled Formal Definition of Definite Integral.